Well, good afternoon and good morning, everyone. Welcome to our virtual road trip. I'm Molly Berry with ATS, and I'd like to thank you for joining us today as we visit with Travis Walbeck for a national update on balanced mixed design. So he's going to review the NCHRP Project 10107, as well as the changes and results from the 2020 NCAT survey focused on balanced mixed design and the status around the country. So he'll provide great resources for all things balanced mixed design. So I'm sure we're all Zoom experts by now, but just as a reminder, here are the controls that you need. You can adjust your audio settings. You can raise your hand if you'd like to address Travis or Tanya audibly, and you can type any questions you want in the Q&A box. So today, Travis Walbeck and Tanya Nash are navigating this road trip. Travis has over 20 years experience in the asphalt industry. He's currently the training manager and an engineer at NCAT. He's a Utah State Aggie and maintains his professional engineering licenses in Utah and West Virginia. Tanya Nash has been part of the asphalt industry for 18 years. She earned her bachelor's and master's degrees from the University of Florida in biomedical engineering. She is a professional engineer licensed in Alabama and Florida, and she's our pavement materials engineer here at ATS. I think that's all the housekeeping points. So Travis, we're ready to depart. Enjoy your trip, everyone.
Sounds good. Thank you, Molly. All right, so I'm going to attempt to give you guys a little bit of an update on what we're seeing from the national level on balanced mixed design. A little bit of an update. You know, we did this really great survey back in 2020, but things have moved quite a bit since then. So we just want to recover a few things there. So the first thing I want to do is make sure that we've got ourselves a good foundation underneath ourselves. And I like using this FHWA definition of balanced mixed design that says basically asphalt mixed design is using performance tests on conditioned specimens to address multiple distresses. And we're going to take into account a bunch of things. We're going to take in our climate, our traffic, mix aging, which is still another very hot topic, and the location within the structure and the pavement. And I like to borrow this slide from an FHWA training session there to kind of put that together. So why do we need the change, right? I think we all know that SuperPave helped us a lot with addressing rutting, but it gave us a really big cracking problem. So there's some key properties there in SuperPave. So our air voids and our effective binder are two of the biggest parameters there. You know, so what air we have for durability, for the freeze and thaw, and letting things happen that way, and then kind of what the thickness of the asphalt is around our different aggregates there. But those volumetric properties don't tell us anything about the quality of the binder. They don't tell us anything about the effects of different additives that we may be putting in there, or the effects of different recycled components. Basically, it's really just looking specific gravities. So we've got, you know, the mass of this and the mass of that, take that through and come up with our volumetric properties that way. The other thing is that the effective binder is very dependent on the specific gravities of our aggregate. And you know, although those stay fairly consistent, they can shift over time. We get in a different vein in a quarry, we may end up with a little bit different specific gravity there. And sometimes agencies are not verifying those on the frequency that they may be up to. We also have a low level of precision with that test, and our wrap specific gravities. The aggregate on our wrap could be questionable because sometimes we're not getting those tests done at that level. So with our balanced mix design, again, we're really trying to balance our asphalt content between a couple different parameters to adjust for rutting on one side and adjust for cracking on the other. We want to bring that asphalt content back to where we don't have a problem with either one, and we can provide the maximum durability for both. So we're going to use that some performance tests to come up with some, you know, index parameters that can give us a level of comfort that we are going to have that binder content in the appropriate place. So those we're going to try to make sure we get those specimens, and we're going to test for the mode of distress that's the most prevalent in our region. So a test that may be really helpful in, say, Vermont may not be the right test for Arizona because we have dramatically different climates in those two regions. So we want to make sure that we're looking at our tests that way. I think it's really important to talk about what balanced mix design cannot fix and cannot do for us. So it's not going to provide significant resistance to reflective cracking, right? We're still going to get that reflective cracking coming through. There are some tests that look at that kind of distress, and we can work that direction, but we're not going to stop it completely. Stripping is another one that balanced mix design still needs to have some sort of moisture susceptibility test, and that can be built into our Hamburg rutting test, or that can be a TSR on the back end as well. Another thing is, if we get incompetent leveling courses or scratch courses, as we called them in West Virginia when I was there, if we're not getting a mix that's down and that's got the durability that we need underneath, and we're not bonded, we're going to have trouble. So even if we take the most Cadillac premium mix and we put it on top of mush, we're not going to get the performance we want. So I want to make sure that we call that out and say that these are problems that we're not going to solve completely with balanced mix design. So what about implementation? Where are the states headed with implementation, and other agencies as well? Now, so through the NCHRP 10107 project, which is the draft report is done, but it's not been published yet, and some other work that's being done by University of Nevada at Reno with Adam Hand, NCAT and Adam and FHWA have come together and come up with this 8-step implementation roadmap. And so that starts out with understanding what the need is, going through some overall planning, selecting the performance test that we want to use, establishing our baseline data. I'm sorry, I skipped there. Performance testing equipment, then establishing our baseline data, specifications and program development, training, certifications and accreditations, and then into what we would call our initial implementation. So I kind of want to lump a few of these together as we talk about them today, and instead of spreading them all out and going into detail, because there's plenty of other venues that we can get that really deep discussion on these different ones. But understanding the needs, we've already talked about the super pave brought us a cracking issue, but there are maybe other durability things that we're trying to look at. If we have raveling issues or anything else, we want to say, okay, what is it that we're trying to solve? Maybe we're in an agency that still has some rutting, and we need to address that. But we want to find out kind of what is the need we're really trying to address here. And do we need to make a change at all, right? That may be a question that needs to happen in that understanding the need. The next is overall planning. And this overall planning would be a place where we would probably want to find our champions within our agency and our champions within the industry, because really working together is the most beneficial way that we're going to bring any sort of a change or any specification really to fruition here, is by working with that partnership. We can identify those things and then start to talk about, okay, what level are we going to ask for balanced mix design? Are we going to do this just on the front end? Are we going to do it for front end and verification? Are we going to run it through production? Let's start to have some sense of how deep into our program we would like to have that kind of testing. So these are some of the things that need to happen through those processes, that planning. Also maybe put a timeline to ourselves, right? How quick do we want to do this? How quickly can we move? Because is our industry and our agency in a position that we can move nimbly enough to put this in place in 2 years' time? Or do we need more time than that? The next would be to select our performance test. So selecting that performance test, again, we need to look at the mode of distress that's the most prevalent in our region. And there's different tests for different things. And you can see I've got a whole gamut of different tests that are displayed here. And they look at different things, and they range from very simple to extremely complex in sample preparation and reviewing the data. Our rutting tests are fairly simple up there on the top, but when we get into cracking, there's all sorts of different things. The next is look at our performance test equipment. It's probably most appropriate that both our design labs and our agency verification labs or review labs have this equipment. And it's a challenge at times for some of our agencies to purchase equipment and get stuff in there. So some of these we can put together with equipment that we already have and say just a few $1,000s for a new jig that can be used on a load frame or something along that matter, or we can spend tens and tens of thousands of dollars on new equipment. We also need to kind of keep in idea there, what kind of impact is that going to have on our industry partners? Are we going to have an issue there that we're trying to ask each lab to come up with, tens of thousands of dollars for equipment to go in each production lab, or are we going to have only something in our design lab, or can we use a simpler test that can just add maybe a few $1,000s worth of equipment into their system. The next one, I've kind of listed this one out further because I think this is really kind of our most important step in this process, and that's establishing our baseline data. We need to come into whatever test that we're going to do with some sort of a knowledge of what our mixes in our region are going to do with these different performance tests. So that being said, the parameter that works in Florida may not be the parameter that North Dakota wants to use for a cracking test, right? Maybe they choose to use the same test, but the materials are much different. What we're going to see in different regions is going to have an effect. What binders are available is going to have an effect there. So we need to review that historical data and information that we may get from our pavement management system. Let's find some mixes that we know we're happy with, that we think are performing quite well in the field, and let's test those with whatever test that we're choosing to go forward with and help ourselves come together. Then we should get into doing some sort of benchmarking studies. Let's test a whole list. Maybe we spend a year of testing every single mix that comes in through our system to try to say, okay, where do these rank out? What are we seeing as differences? Are we tracking our sources and finding out, this binder seems to do well with this test, but this binder, even with the same aggregate structure, is not doing quite as well. And some of those things can help us determine where we are. Definitely want to make sure our mixes are correlated back to our known field performance. We may want to conduct some shadow studies here, right? Maybe we're going to say, okay, this is what we think we want to test, and for a project or two, we're going to pull the additional samples during whatever process that is, verification, production, or so forth, and test that and see, okay, would this mix pass? Would this mix meet the standard that we think we're wanting to set? I want to make sure that we're analyzing all that production data, right? We're going to find variances between our mix design and what's actually produced in the plant. So let's analyze and verify that if we are choosing to go to any sort of a production test, are we making sure that we can still pass those tests on a mix that we're relatively comfortable we'll pass the test in any other way. And then we want to determine what kind of adjustments we're going to allow in that process, what kind of things can be adjusted, not have to go back to a new design or not go back to some sort of a verification process there. But this is such an important step, and it may take a lot of time to come up with these. I think round robins become important at this time as well. Let's send some mix out throughout both our agency where we know the tests are going to happen and our industry partners. And that includes consultants that may be doing third-party testing for our contractors or hired in through our systems. But let's make sure that we get plenty of testing done. Let's gather a lot of data and make sure we have a real solid level of comfort with where our mixes are. Let's say, for instance, we go out and we're going to choose what is the most popular test right now for cracking, would be ideal CT. Let's say maybe we decide, okay, we like a number of 50. We picked 50 because that's the average of the mixes within our state. Is that really where we want to be? Do we think that half of our mixes passing and half of our mixes not passing is the appropriate place to be? I think that's a decision that agencies need to make themselves, right? Maybe they are happy with the majority of their mixes. That number could be lower. Maybe they want to try to do something to try to raise the bar in their agency, to raise the level of quality in their material. So we maybe set that higher than what the average is to try to up that quality. And again, these are decisions that need to be made at that agency level. Tough decisions. I don't envy those of you that have to make those decisions. As we move forward here, we need to get into specifications and program development. How are we going to write the specification? How often are we going to test? Especially if we go to production, are we going to do once a day? Are we going to do once per lot? Are we going to do once per sublot? All those things need to be worked out and realistically evaluated as we go in through a specification process. Find out whether or not we're gonna have some sort of pay incentives or disincentives attached to this kind of testing, and really work that through whatever process we have. The next one is a bit tricky: our training, certifications, and accreditations. All of us like to make sure that we have certified people in our laboratories. It's an FHWA requirement, but it's really the right thing to do as well, to make sure that our staff know the tests, that know what they're doing, that they know how to interpret the results, that they can see if something's off a little bit, wait a minute, what's going on here? Let's go back and make sure that our calculations are right, that our sampling was right, that our sample preparation was right. So we need those folks that have that there. One of the unfortunate things about a balanced mix design test that we see listed now is that we're not seeing many of those that are already a full standard in either ASTM or the AASHTO system. And for the AASHTO resource group to come in and do some sort of evaluation or even get into proficiency sampling for a specific test, it first needs to be a full standard in one of those systems. And second, they need to have enough requests from agencies or contractors that are using that test to start to put it back into their system. So we've got some work to do as an asphalt industry to get those standards to where we're comfortable enough to make them full standards before we can even get into accreditation. So that makes some of the certifications and trainings challenging on where we do that. So oftentimes we're seeing that states are needing to do that themselves. Other times they're asking, groups like Asphalt Institute or NCAT to come in and help with training and bring that kind of up to level there. The next thing to talk about would be the implementation, right? This initial implementation, where we're going to go ahead and say, okay, we're putting projects out there. So sometimes we're going to do pilot projects. Sometimes we're going to pick a handful of projects and put it out there and make sure where we are. And there's several states that have not only done this, but they've seen several years of this happen with our balanced mix design at this point. But the thing that I think is most important to talk about here is we need that feedback loop, right? We go through that initial implementation, and then we need to come back, get in through some of those steps. Is our specification what we wanted? Is our baseline where we wanted? Is our test the most appropriate test for what we're trying to accomplish? And so we need that loop to happen for some time to make sure we really got what we wanted as we talked about our goals and what we tried to accomplish with balanced mix design. So next, let's talk about some of the implementation efforts that have happened in different states. And as Molly mentioned, we did a survey back in 2020, and we were able to get all 50 states to respond to that, and that worked out really well. I feel like there's some information that's a little more up to date than that at this point, and that's what I want to show you guys today. To set a foundation for that, we want to talk about the 4 different approaches to implementing balanced mix design. And this is some information that's listed out in AASHTO PP 105, and it goes through 4 of the different ways that it can be implemented. The first one, or what we call approach A, is a volumetric design with performance verification. And this is the most comfortable. This is our old recliner, all right? This is taking our volumetric mix design process that we're all used to. We're going to go through the entire process, and at the end, we're going to tack on a few extra tests. We're going to tack on a cracking and a rutting and make sure that we pass those 2. If we fail, go back to the beginning, start all the way over, come back through and do those few tests. So this leaves very little room for innovation, and it actually kind of handcuffs our mix designers and drops them into an even tighter window with the materials that they're working with. The next approach is volumetric design with performance optimization. So with this one, we're going to move those performance tests up in the process a little bit. We're going to select our materials. We're going to figure out what our aggregate structure is, and then we're going to perform our performance tests on multiple asphalt contents and determine our optimum binder content based on what our results are from there. And so this gives us a little bit more comfort that we're finding a range in there instead of everything starts back over. Now we have a little bit more room to play with there. Gives us a little bit more room for some innovation, not nearly as much as some of the others. Approach C, or the third one that's on the list here, is performance modified volumetric mix design. With this one, we're going to use our performance tests up front. We're going to pull our volumetric numbers at the back end. We're going to pass both still. We're going to pass our performance tests first. Then we're going to make sure that we pass what we're comfortable with our volumetrics. If both come together, then we're going to move forward. The last one is performance design. With performance design, we are going to rely heavily on our performance tests. We're going to rely on our cracking tests. We're going to rely on our rutting tests. And we're going to need to let some of those legacy tests go. We're going to need to maybe relax air voids. Maybe we're going to relax fine aggregate angularity. Some of those properties that we've really held tight to over the years, we maybe need to let back a little bit. This is going to allow a lot more room for innovation. It certainly is going to allow more room for different additives to be used that maybe can help us put more recycled material into our balanced mixes. And so again, this is listed out in PP 105. There's a couple other resources out there. There's a further discussion that you can find on the NAPA BMD resource guide website. I've listed the link there. I think Molly's going to send out some of these links to those of you that give you some resources that we kind of recommend there. But that's another great place to go read some more about those different approaches. So as we look here, this map here is published on that NAPA Balanced Mixed Design resource guide, and this is updated. In fact, I looked at it last week and I looked at it this week, and it was different this week. So I made sure that I put the most recent version of this up here. But we can see a couple different things that are going on here. So we have these states that are kind of in this kind of darkish purple here are going to be the ones that are using Balanced Mixed Design Approach A. That's the volumetric design with performance verification. This is the comfortable one, right? So we can see that there's a handful of states that have decided that's the way they want to move into Balanced Mixed Design initially, at least initially, and see how things go there. A couple of states have chosen to have more than one Balanced Mixed Design specification for different kinds of projects, different levels of projects. Those are New Jersey and Virginia. And so they have a couple different approaches. So we can see that New Jersey has an A and a B, and we can see that Virginia has an A and a D, right? And so I'd rather let them speak about why they're using different ones in different projects, but nonetheless, they are using a couple different processes there. We go to this other purple, that's going to give us, I think, just Missouri that's using strictly approach B. We've got a couple states using C, and we've got a handful of states, a couple there that are trying to use that approach D. And that's the one to let things really go. And I think that's being done on a limited basis at this point, that it's not widespread, but they're trying to move that direction. And then there's a lot of states that are using that light blue color there that are in pre-implementation, that they are probably doing their benchmark studies. They're probably looking at what their specifications are. And then quite a few of the states that are still in gray there, we know have already started some sort of process. In 2020, when we did that survey back then, 44 states had at least identified a group of people that they wanted to start working down the process and start to pick tests. So there are a lot of agencies that are doing work that aren't ready to say this is the approach that we're picking. So what is my state doing? What is your state doing? One of the things that I think is kind of nice about that website is if you are to click on the state that you would like to know about there, that's got a colored slide on it, there's these one-page reports that have been put together that kind of summarize what's been done there, lists a few things out there, what approach they're doing, what tests that they're working with, and has some more discussion about what their specification is. So feel free to get on that NAPA Balanced Mixed Design resource page and go through there and see what either your state is doing or what your neighboring state or a state that you're interested in is doing to try to move themselves into Balanced Mixed Design. But these are what those one-page papers look like. So as we move on to, now we've decided what approach we're going to take, let's talk about our tests, right? So there's a bunch of tests to pick. Which one to pick? Well, AASHTO again has got ourselves a standard out there, right? There is an AASHTO provisional standard here on MP46, and that identifies performance tests that could be used in Balanced Mixed Design. All right, here's the thing. It's got 5 tests listed for rutting. It's got 13 tests listed for cracking, has a short description of each one, references back to what may be a provisional standard for those different tests. And each one has a table of suggested criteria. Each one. Here's the trick. Each one has suggested criteria of to be determined. So I get a kick out of that. It's entertaining to me that that we list those tables out that way. But this really comes back to that benchmarking. It comes back to local materials. It comes back to available binders in the area. What are our aggregates going to do with binder A and binder B? And what happens if we have a binder source change? Are we still going to get the same results? Because several of these tests are very sensitive to our binder, the quality of our binder. So I think it's important to know that although these tests are listed out there, that it's still up to the independent agencies to come up with what their criteria needs to be for those tests. So, and I think that goes back to, like I've said, it goes really back to that establishing baseline data and going through each of those steps to make sure that we select the criteria that's most appropriate for our agency and our region. So as we go through and we look and see, what different rutting tests have been selected across the nation, I think it's interesting that some of these tests that are listed in this slide here some of the states have not necessarily selected their implementation approach yet, but have maybe already selected their tests. And so they've not dialed it down in that way. That, you know, those 8 steps don't have to go chronologically in order. There's some mixing and matching and some things that are going to happen at the same time from step to step. So we can see here that across the nation, the Hamburg Wheel Tracker is probably the most popular test that goes across the nation here. There are California's using the flow number coming out of the AMPT along with the Hamburg. Alabama here is using the hot IDT test, and it's really great for a production test as well. So it's a really simple test to perform, and New York is using that as well. And then we've got definitely some states that are kind of in the Mid-Atlantic and Midwest area there that they're using the APA. You know, all of these tests are good tests. There's not one that we recommend or say is better than another test, but here's again that list, and this map's available again on that NAPA Balanced Mix Design resource page. So we move on to the cracking tests. We have a whole bunch of different options here. There's 13 listed in the AASHTO, right? There is a lot of different tests to pick from. And I think it needs to be said again that it's important that what agencies are selecting their cracking test for balanced mix design, they really need to look, what is our predominant distress? What is the cracking mode that we are trying to address? Is it low temperature cracking? Is it mixes that are just plain drying out? And we need that flexure, you know, we need that additional binder in there to fight that. Is it reflective cracking? Do we need to find, you know, a test that helps us at least slow that down? We may not stop it, but at least slow that down. And there's a handful of states on here that have selected rutting tests, but are not necessarily selected a cracking test yet. So that's kind of indicated as well on that particular slide. So what test is best for us, right? This is a big challenge to say what test is going to be best for us. There is a whole bunch of cracking tests there. Fewer, but still not dialed into a single or just 2 rutting tests to pick. So, you know, there's some resources out there to help folks kind of determine what would be the best test for them. And there was a little special report that NAPA put out as well, Special Report 227. And it goes through a few different steps that an organization could use to try to select which test would be the best for them. So, you know, some of these considerations that are listed there is, you know, it must correlate to field performance. And I think that is the paramount thing. We have got to find a way to make sure that whatever test we're doing in the laboratory that we want to be based on the performance of that mix really does correlate with what happened in the field. And there's been some accelerated testing done. You know, NCAT in our previous cycle did a cracking group there where a handful of tests were used in the laboratory. The mix was put out in the field, and we ran the traffic over the mix itself on the field, those test sections, and correlated things back. Found great correlation in some. I think some were not as good correlation as we had hoped. But even at that, you know, that's 2 years worth of environmental and with the accelerated 10 years worth of traffic. And so if the traffic is not our predominant distress there, we may need to look at tests that we could evaluate further over time. But I think that really is the thing we really need to work hard towards, is making sure that our tests are coming back to whatever field performance we're seeing. We want to talk about timely results, especially if we're going to get into production testing and balanced mix design. You know, it's really not very reasonable to ask a contractor to make decisions about placing mix if we're not going to have results back to them for a week, a month, right? You know, if we're going to do Hamburg during production, you know, we've got about a minimum of 3 days from the time that we pull a sample till we're going to have a result back from them. You know, unless we've got folks working around the clock to do that. So as we're selecting a test, and it depends on what phase we're in the design phase, that doesn't matter nearly as much. If we're going to do production or verification of a mix through the plant, we need to really think about how timely can we do this. And then the test should be something that's affordable for widespread use. I think I already talked about that during the equipment selection and determining the test. You know, there's some tests that are just a few $1,000s investment in you know, can use maybe a load frame that most labs already have. and others that would take an extreme investment in not only the testing equipment, but the equipment necessary to fabricate the specifications that need to be done there. So we really do need to keep that in mind. Is this test something that's going to be affordable for us across the board? You know, ease and safety of fabrication. Some of these, it takes days to get the sample prepared to even go in the equipment to do the test. And so that's where we're seeing some popularity in things like the ideal cracking test, like the hot IDT rutting test. Those are very simple sample preparation. And so we see that come together really quick. Variability should be low as possible, right? If our results are all over the place from one lab to another, then it's very difficult if we're going to use a balanced mix design for any sort of acceptance. It's very difficult for a contractor to pull that in if we have high variability between labs. So we want to certainly make sure that we've dialed things in that way. And then the results and the analysis should be straightforward. You know, we want to make sure we can come up with some index or parameter that's easy to discuss and easy to communicate back and forth. And this report can be found at that link. And like I mentioned, I believe Molly's going to send out links on where you could go find the document that this is just the list of there's a couple pages worth of reading there. If you're looking to try to pick a test, I think, you know, I'd recommend this reading here. I plugged that website a couple times here. I think it's a really great place to go find some resources. If you dial down in there, there is all sorts of stuff going on. You can find those maps that I've talked about, what other states are doing. The next thing is that we can dial in and look at the different tests, right? So there's guidance on selecting tests. There's guidance on trying to come up with what your criteria ought to be. And then as we go through, if you're able to get on that website and go down through there, most of the tests that are listed in the AASHTO document are also documented here. There's a couple different ways that you can learn about the test right from this website. Probably one of the easiest is there's these one-page documents. Some of them slip over into two, but they're these really simple documents that have been put together to help communicate what the different tests are and let people go through and analyze and help them make a decision on what test may be the best for them. There's also videos on quite a few of the tests on how to perform the tests themselves. Gives you an opportunity to look and say, okay, what are some of the challenges? What kind of equipment do I need, et cetera there. This is ongoing work that NAPA is doing. They are continuing to build that library. We're looking to put some more videos together for them and put on that website and partner with other folks to make sure that we're getting great information on that particular page. There are lots of training opportunities out there. Back in 2018 or 19, there were workshops that started going around the nation, and NCAT was very involved in those, going around from region to region and starting to talk about what balanced mix design is, what different things need to be considered as you implement, what things need to be considered as you try to select tests. Those went on down through the pandemic and they went to Zoom, right? So they started being state specific at that point. But through this NCHRP 10107 project that NCAT and ARA are working on together, there are going to be another round of regional workshops that come out that are going to really dive down into those 8 steps and the sub steps that are within those 8 steps and really help agencies and contractors and folks that are shareholders in the asphalt industry understand the different things that need to be done to try to move ourselves towards balanced mix design, if that's the choice that we're going to make. So those are kind of all over the place. Back in September of 21, there was a balanced mix design conference that was held in Nashville, and there were some really great discussions, had some really good presentations by different states and what they're doing to implement, what they've seen so far as if they've been working towards implementation or they've seen projects go down in the field. A recording of that is available. There's a link again there that goes to a page here at NCAT that we have some resources for balanced mix design on a page of ours. And there is a recording that's been uploaded to YouTube that you can link from that particular place there. Make a bowl of popcorn. There's 5 hours worth of video from that conference there, but you could dial in through this agenda and go and watch the different things that you'd like to watch. But that's another resource that you can continue to learn from. My hope is that we find a way to continue doing that balanced mix design conference and continuing to talk about this on a national level so that we can help each other out across state lines from region to region and really help us move our asphalt industry forward that way. So there definitely are more resources to come. There's more workshops that are going on. There's more training that's going on. There's all sorts of things that can be done if an agency needs help or wants help. There's more than one resource to pull from for that kind of training resource. So a couple things kind of in summary here is, those 4 approaches are important. We need to figure out which one we'd like to use. I'll give Molly a bone here. There's even a training in your pocket video that NCAT's put out. It's on YouTube that goes through and in an entertaining way explains what those different approaches can be. If you're not familiar with that program, just search training in your pocket on YouTube, and that'll put you on to that. Again, they are technical, but we try to make them entertaining as well. Throw you a couple of dad jokes in there when we can. So several states have already chosen their approach that they want to use. Approach A seems to allow less room for innovation, right? Because we're just adding extra tests on to what we already been doing. Approach D is going to allow us more room for innovation because we're going to let go of some of those legacy parameters that maybe limited recycled use or limited using different additives in the past. And so that approach D allows for that additional innovation there. The balanced mix design tests are kind of listed, not, out in the AASHTO MP46. Again, those criteria tables are there, but each state should set their own. They should do the work to figure out where they need to be. And I know from my time in an agency, what happened across the state lines wasn't necessarily the same thing, and didn't necessarily have the same resources available to contractors in just a few hundred miles away, didn't necessarily have the same resources available. So that's why it's so important that each agency looks at this on their own. So many states are in the implementation phase. I think there's some 12 or so states that have got balanced mix design style mixes on the ground already and are starting to look at what that field performance is going to be, starting to look at the constructability of the mixes and so forth. And I think that's great, and hats off to those agencies that are out there that are being proactive about that. There are lots of resources and trainings available. So between workshops, there's different things that are being done. We offer a course here. You can come in and learn for about 3 days how that works. There's lots of resources out there. That NAPA page is a great place to learn about it. There's a small resource page on our NCAT website, but there's a lot of information out there. Things are kind of being pulled together, and we're trying to move things forward that way. So, Tanya, given that, maybe you can help me field some questions.
I am here for you, Travis.
Thank you. I've got to give my plug. I'm ready. I'm ready for my soda now.
Yes, it's always do with Travis. Well, Travis, I really appreciate that. It's a great update. And as we know, the balanced mix design is a super hot topic everywhere you go. I don't think you can really go anywhere. Even in the sustainability aspects of conversation, balanced mix design always finds its way to squeak in there in the conversation. I do have a couple of questions for you, just in the sense of big picture. So now, balanced mix design has been around even in conversation for quite a while. I mean, several years. I think I've seen it go back as far as 2007. I think some people have discussed a little bit about it and then started trying to kind of play around with it. And as time has gone by, now we've gone through a lot of progress and as of late, and a lot of training, and people have really started kind of digging through this. What would you say, in your opinion, coming from an organization that's really heavy in this development, that would be the biggest lessons learned through this whole process?
So I think there's a couple things out there that are important. I think one of the biggest lessons that I've kind of started to pick up on is that sample preparation in our testing is so important. There was some round robin work that was done here back in, I think, 16, 17, 18 time frame, where we were trying to validate some tests. And I say we, that was before I was here, but nonetheless, my good friends that work here and have been here a long time were part of that. And they sent mix out and said, run this specific test and report your results. And they got a tremendous amount of variation. I said, man, this isn't right. We don't see that variation when we do the test here. Can multi-lab really be that different? And so they decided to take that on to the next level. And they said, okay, we're going to compact all of the samples here. And we're going to send the samples out and ask them to run the same test again, tighten way up. And through that, they learned that the air voids was a huge, huge deal with that specific test. And so I think that when we come back to what that sample prep is, becomes really, really important. See, there were two other things I had in my mind there. I think another thing that still needs to be figured out, Tanya, is aging, right? What kind of critical aging are we going to do? Are we going to age loose mix and then put it in? Is that really the parameter we want? Is that going to give us the results we want? Is it going to mimic what we think comes down the line? Is it going to hinder the contractor from being able to make decisions? Is it going to artificially age the binder in a way that we wouldn't naturally see in the field? So there's a lot of discussions that are happening about how we're going to actually age those specimens.
100% agree. Did you think of your third? I see you thinking.
No, I had it teed up there, but I don't recall what it was.
Okay, well, if you do think of it, chime in, even if it's random. Go ahead and throw it out there.
Okay.
But we do have some questions from our participants. We have one from Andy Babish, who is asking, are the states requiring BMD performance testing during production or mixed design approval phases only?
So I have seen it in both. Okay, I've seen it in both, and I think that's why we go through that discussion there. And I know I see Johnny on here, he's commented as well, and I know he's going to be intimately familiar with what's happening there in Virginia. So Rob Crandall was on here as well. He's going to be really familiar with exactly what they're doing. But I can give you some examples that the counties in Alabama wanted to move towards balanced mix design, and they didn't want to wait for the DOT. And so they put together a very simple specification where they had been doing tests during production. So for that instance, just to give you an example of how they're doing that, they're pulling an AM sample and a PM sample, and they're running an ideal CT and the hot IDT test. If you're not familiar with the hot IDT test, it's the same pretty much sample as the ideal CT, but we're going to heat it up to, I think it's 122 degrees Fahrenheit, and then we're going to break it. And it's a different formula. We're looking at that strength at that point as an indicator of our rutting resistance. So we do see that at that point. There's several that are doing different things with the mixed design process and leaving it there. And I'm not aware of any, but I think it's worth discussing that there are some agencies that want to talk about, let's do the balanced mix design during design phase, and let's do it during verification phase, where we're going to verify the mix can be run at the plant. And after that, let's reference back to our volumetric tests that we're familiar with, that we know work quick, that we know work, and see if something changes dramatically, then let's go back. But otherwise, we're going to let things go just at the verification stage.
Okay. Speaking of Johnny from VDOT, so Johnny, which does have a comment or a question for you. It says there's a very unexpected but expected question from a lead state in this push for balanced mix design, and asking, are these balanced mix design efforts worth pursuing? Johnny,
that's not fair. Not fair that you asked me that. You know, from my perspective, I think it is. You know, since Super Pave was implemented back in the 90s, I think it's 46 states have made some sort of variation to that to try to bring the durability back into their mixes. You know, we solved the rutting problem. We did, you know, and through different things, but we brought on a cracking problem that was absolutely embarrassing, right? And we've seen premature cracking all over the place. So states have changed their gyration levels. They've changed their BMA limits. They've done air void regressions. They've done all sorts of things. So balanced mix design really does seem to be a very promising way to try to swing that pendulum back and see if we can get it to stick in the middle a little bit between rutting and cracking. So I do think that it's worth it. You know, I'm trying to help my former state move forward with it. I think it will be very helpful for them. So I think it's the right way to go.
Okay, we do have a kind of a combo question from Gary Hoffman in Pennsylvania. And Gary's asking, what do you believe is an acceptable level of COV for ideal CT test results?
So I am not your heavy lab guy. So I'm going to defer that question. In fact, Gary, I think probably the most appropriate thing to do is that I'm going to visit with some of our lab staff that have been validating these tests, that have been doing all sorts of tests, all sorts of round robins and looking at them, and let me discuss that with them a little bit, and then maybe touch base back with you.
And Gary, from a standpoint of testing, from a labs aspect and multi-lab and then kind of in lab, I would say that for COVs and ideals, if the sample prep, if you're really, really paying attention to your sample prep, you can be within that 15 to 18% range. You're probably, if you have a sample prep issue, I've noticed them drift a little bit higher into the high 20s. And that's usually your trigger for maybe something wasn't quite right, either temperatures or maybe your samples are a little bit off. But usually you can sit right at that 18 on average is a good COV. Now you do get slightly more of a variability once you start moving into field samples and cores. But if you're doing lab and lab prepared samples, or from the plant mix or lab mixed, you should be right in that pocket. So his follow-up question is talking about, in setting the thresholds, are you testing strictly lab prepared samples, or are you also looking at production mixes and field cores from construction projects? So I guess to rephrase a little bit, Travis, do you know whether or not some of those studies have combined both field samples and lab samples?
So I've not looked at studies that are looking at that production. I do know that there is that information out there. I know that there's production data, at least from the Alabama group, that's done that. There are several states. I think we've got, sorry, not states, counties. I think there's about six counties or so that have been using that. I've not looked back through the data with them to try to really look at that. I do think it's worth bringing up here, though, that field cores, if we're going to do field cores and put these performance tests on it, we need to understand that we're also looking at construction variability at that point, and even the underlying material variability that may be introduced into that testing if we actually pull the core. Now, I think there are definitely things we should look at that way, but if we're looking at the mix, and is this mix being produced going to meet those performance parameters, or at least the indexes that we're putting in this test, that we may be bringing variability we don't want in by pulling samples from the field, from the roadway.
Yeah, and if I may try, I agree. Please. That there is a very much of a shift between when you actually do your mix designs and perfect world scenario, you're measuring things out to 1/10 of grams and you're getting everything exactly perfect the way you want to see it. So that should be your, not to do a pun, but your ideal situation of what you're actually going to get out of your performance numbers. And then just like everything else, when you produce something through a plant or you pulling something from a field compaction, you're looking at a variability that is not accounted for during the mix design. So you should have that plus or minus range within that for that test, for that design. So Travis, I do have another question for you related to the track. And I know that there are some states that have actually used balanced mix design on this cycle for the track. They're looking at, traditional volumetric versus balanced mix design. Mm-hmm. Do you happen to know, I'm going to put you on the spot, I'm sorry. Do you happen to know the states in those sections that, we could possibly go and follow to say, hey, this is kind of what their balanced mix designs are doing?
I don't. I can tell you that I'm pretty confident Alabama's going to have one, right? Just because of the partnership and the way that's always worked over the years. But honestly, I apologize, Tanya. I don't know which states have sections on the track that do have balanced mix design in them for this 8th cycle. I apologize.
No problem. I'm sure we can get a quick buzz answer from the from the track.
Right.
Let's see. So I guess along the lines of Johnny's question, my last question would end up being, you have the balanced mix design, which a lot of states appear to be pretty proactive in, and they want to try and jump on the bandwagon of, hey, you know what, I can do this too. But I guess the question is, you know, if your pavements are performing, or if you feel like they're doing pretty well, but you may have one or two little tweaks to it, is this just another change for the sake of changing, or is it just another thing? If you're going to do same, so if I'm benchmarking and my volumetrics benchmark my performance parameters, what is there any benefit to doing that? Because you want to do improved performance, correct? So the volumetric side of that is giving you this line of performance. Your performance numbers should be giving you this. So, but if you're performing fairly well in the grand scheme of things, is balanced mix design really a good fit for every state that you see right now?
I think it's a state by state decision. I really do. You know, there's some states that are walking very gingerly into this. They're saying, you know, we're going to do some testing so we don't get left behind. We're going to watch what we're doing, but we're not really feeling like we need to move forward. There's a state that's done a major change to super pave, and they've said, you know what, we are really confident with what we've done here. We've done it for a few years, and we're going to watch balanced mix design, but we're not going to move that direction. And then there is a whole handful of states that are saying, we're just going to wait and see what happens with this thing, right? But I don't feel like it's a change for the sake of change. I really don't. As I mentioned earlier, there's some 46 or so states that did some sort of modification to super pave to try to reduce the cracking, to try to get the durability back up where they felt their mixes were, before super pave was in there. So I really do feel quite confident that this is the approach to take to try to swing that pendulum back towards the middle again and get both the durability on the cracking side and resist the rutting.
Okay, and I lied, I do have one more question, sorry. So I know that NCAT is gearing up to try and come back to the balanced mix design workshops. Now, if you were a participant in the very beginning when all the workshops started, is there a benefit to reattending any of these workshops? Will you be going over more and more in depth and better refined?
Unequivocally, there's benefit to that because so much has been done through this NCHRP 10107. So once those steps were established and we were relatively comfortable with where things are there, NCAT has gone back out and gone to individual states and sat with them and gone through those steps and said, how does this work with you? How does this work with you? How does this work with you? Can you do this? Can you accomplish this? Can you accomplish this? And refined what's going on. So with that and the information that's been learned, and Randy West and Tanya are very in tune with what the different states are doing there. They're absolutely, if you went to one of those first ones, there's absolutely value in attending one of these subsequent ones and seeing lessons learned in the time, seeing how things have shifted just a little bit over the time.
Yeah. Well, thank you so much. As always, you guys have a fantastic training program and training in your pocket, which I absolutely love. So it's not just Molly and us. Hopefully everybody else is out there watching it as well. So I really appreciate your time, and I'll send it back to Molly to close us out.
Thank you guys. Great information. You make me laugh a lot too. Those NCAT training in your pocket videos, if you guys have not seen them, go check them out. Like Travis said, you can just Google NCAT training in your pocket or search for it on YouTube. They cover a lot of our industry hot topics and concepts in a very high level and witty way, full of dad jokes, like Travis said. So if you have new team members or new employees, that's a really great way for them to get introduced to our industry too. As Travis mentioned, I will send links to all the references he made, so you'll automatically get an email tomorrow or Thursday with that information. And going back to ASHTO PP 105, Travis, that you were referencing, I noticed Alabama and Tennessee are two of the states that use that approach D, which allows for a little more innovation. Like you said, maybe some more additives can be used, and that's a perfect segue to our next road trip, April 13th. Matt Chandler from the Tennessee DOT will actually be with us, and Trey Worst from Ingevity. And we're going to take a look at vetting innovative technologies, looking from a producer side and also from an agency or DOT side, and see what some of the struggles and hurdles are and how to overcome those. So you guys, I'll send a link to that next session along with references that Travis made. And thank you all for tuning in. We'll see you next month. Thanks, Tanya. Thanks, Travis.
Hi, guys.